In the endless, silent ocean of the cosmos, where island universes drift on the slow currents of space-time, there are regions of unimaginable splendor. There are stellar nurseries, incandescent clouds of pink and blue, where gravity is a patient midwife, coaxing new suns into a first, fiery breath. There are grand design spirals, majestic whirlpools of light and dust, their arms laden with the brilliance of a billion young, hot stars, a testament to cosmic order and vigorous life. These are the cities of the universe, bustling with energy, activity, and the promise of creation. But our journey tonight takes us away from these vibrant metropolises. We travel past the bright filaments of the cosmic web into a quieter, more desolate province of the known universe. We are heading toward a cosmic backwater, a region of space notable only for its seeming emptiness, its profound and unsettling stillness. Here, in the constellation Eridanus, lies a galaxy. It does not spiral with youthful exuberance. It does not blaze with the fury of star birth. It is a soft, diffuse smudge of ancient, golden light, an elliptical monolith named NGC 1600. To the casual observer, it is unremarkable. A relic. A galaxy that appears to be sleeping, its most vibrant days lost to the deep past. It is what astronomers call a red and dead galaxy, a quiet ghost town where the fires of creation have long since been extinguished. But within this silent kingdom, within this tomb of forgotten stars, lies a secret of terrifying proportions. For years, our understanding of the universe was built on a simple, elegant rule, that the monsters at the hearts of galaxies grow in proportion to their kingdoms. A small galaxy harbors a small central black hole, a large galaxy, a larger one. It was a law of cosmic ecology, a balance that seemed to hold true across the heavens. But NGC 1600 violates this law. It breaks the covenant. Lurking in the center of this placid, unassuming galaxy is one of the largest supermassive black holes ever discovered. A titan weighing 17 billion times the mass of our Sun, a gravitational singularity so extreme it defies the very models that predicted its existence. It is a king without a suitably large kingdom, a predator in a depleted wilderness. The discovery shattered our assumptions and left us with a chilling question that echoes through the empty halls of this ancient galaxy. How did such a colossal monster grow to its impossible size in a place so profoundly, deceptively quiet? Join us, as we venture into the heart of NGC 1600, to uncover the violent history hidden by its serene facade, and to understand the life of a sleeping giant. Now, let's begin. Music. To truly comprehend the anomaly of NGC 1600, we must first learn to see it not as an object, but as a character, a living entity with a history written in the light of its ancient suns. Imagine a being whose body is 200,000 light-years across, whose form is not solid, but a shimmering, ethereal globe of pale gold. This is NGC 1600. It is an elliptical galaxy, a class of cosmic structures that represents galactic old age. Unlike the flat, spinning disks of spiral galaxies like our own Milky Way, ellipticals are three-dimensional swarms of stars, chaotic and yet bound together by a shared, immense gravity. There are no graceful arms here, no defined lanes of dust and gas. Instead, there is a vast, hazy sphere, brightest at its core and slowly fading into the blackness of intergalactic space. Its light is the color of embers, a uniform, antique yellow. This is the telltale sign of its age. The brilliant blue and white stars, the short-lived, profligate giants that illuminate the arms of younger galaxies, are all gone. They burned through their fuel billions of years ago, exploding as supernovae or collapsing into cold, dark remnants. What remains is a population of stellar elders, red dwarfs, yellow suns like our own but far older, and bloated red giants in their final, luminous death throes. These stars are the keepers of deep time, their light a faint echo from an era when the universe itself was younger. The motion within this galaxy is a portrait of primordial chaos, frozen in time. The stars do not orbit in an orderly, coplanar fashion. Instead, they follow long, looping, individual paths, like a swarm of bees buzzing within a colossal, invisible hive. Their trajectories are randomized, a consequence of a violent and chaotic past. They swing in from the outer halo, dive deep toward the core, and are flung back out again on journeys that last millions of years. This randomized motion is what gives the galaxy its spherical, puffy shape. It is a structure born not of delicate rotational balance, but of brute gravitational force and the accumulated momentum of countless ancient collisions. NGC 1600 is not breathing with the rhythm of star formation. There are no vast nebulae, no clouds of hydrogen gas condensing into the next generation. The raw materials for creation have been exhausted, consumed, or ejected into the void long ago. It is a galaxy in a state of quiescence, a profound stasis. It is a finished piece of cosmic sculpture, its form finalized, its dynamic evolution all but over. It drifts through the cosmos as a self-contained universe, a silent vessel carrying 1 trillion aging souls. This very silence, this appearance of a peaceful retirement, is what makes the central monster so perplexing. In a vibrant, gas-rich spiral, a giant black hole has an obvious food source. It can gorge on the abundant interstellar medium, growing fat and powerful. But here? In this barren, gas-poor desert? The pantry is empty. The silence of NGC 1600 is not the silence of peace. It is the silence of a banquet hall after the feast has ended, where only the bones remain. It is the quiet of a battlefield after the war is over. The galaxy's serene, golden glow is a mask, hiding a past of such unimaginable violence that it left the entire kingdom barren, and enthroned a king of impossible proportions in its heart. The quest to understand the giants at the centers of galaxies is a cornerstone of modern astrophysics. For decades, astronomers have been cosmic cartographers, mapping the heavens and finding, to their astonishment, that nearly every large galaxy they surveyed possessed a dark heart, a supermassive black hole. These are not the stellar mass black holes born from the collapse of a single giant star. These are behemoths, millions to billions of times the mass of our Sun, whose origins are one of the great unsolved mysteries. Early theories struggled to explain their existence. How could so much mass collapse into a single point? Gradually, a picture emerged, one of co-evolution, a symbiotic relationship between a galaxy and its central monster. This relationship is elegantly described by what is known as the M-sigma relation. It is a remarkably tight correlation, a cosmic rule of thumb, that connects the mass of a galaxy's central black hole, M, to the velocity dispersion of the stars in its central bulge, sigma. In simpler terms, the faster the stars are moving in a galaxy's core, the more massive its central black hole tends to be. This implies a deep, regulatory connection. It suggests that galaxies and their black holes grow together, their lives intertwined in a delicate feedback loop. Imagine a young galaxy, flush with gas. As the gas funnels toward the center, it feeds the nascent black hole. The black hole grows, and as it feeds, it becomes an active galactic nucleus, or quasar. The material spiraling into it forms an accretion disk, a maelstrom of matter heated to millions of degrees, which shines with a ferocity that can outshine the entire host galaxy. This brilliant outburst of energy, this quasar feedback, pushes back against the inflowing gas. It can heat the gas, ionize it, and even blow it out of the galaxy's core altogether. This act of self-limitation effectively chokes off the black hole's own food supply. The feeding frenzy subsides, the quasar dims, and the black hole stops growing for a time. The galaxy then settles, stars form from the remaining gas, and the cycle might begin again. Through this cosmic dance of feeding and feedback, the black hole's growth is tied directly to the properties of its host galaxy's bulge. It can only grow as large as its galactic environment will permit. This beautiful, self-regulating picture explained the observations in thousands of galaxies. It brought a sense of order to the cosmic zoo. From the 4 million solar mass black hole in our modest Milky Way to the multi-billion solar mass giants in colossal cluster-dominant galaxies like Messier 87, the M-sigma relation held true. The kings were always proportional to their kingdoms. This was the established law. And it was this law that a dedicated survey, designed to test the limits of this very relationship, was about to shatter. The astronomers of the massive survey were not looking for anomalies, they were looking to refine the rules. But in the quiet light of NGC 1600, they would find an exception so profound it would force us to rewrite the story of how the universe builds its greatest monsters. Music. The discovery was not a single, dramatic moment of revelation, but the slow, methodical accumulation of irrefutable evidence. It began with the Massive Survey, an ambitious project using some of the world's most powerful telescopes, the Gemini and McDonald observatories, to peer into the hearts of the most massive, yet nearby, galaxies. The goal was to weigh the central black holes in these giant ellipticals, galaxies that represented the upper end of cosmic evolution. The technique they employed is a marvel of indirect detection, a piece of celestial forensics. One cannot see a black hole directly, its gravity is so strong that not even light can escape. So, astronomers must look for its influence on the things they can see, the stars. The principle is simple, derived from the laws of gravity first laid down by Newton. The more massive an object is, the faster another object must travel to maintain a stable orbit around it. By measuring the speed of stars orbiting a galactic center, astronomers can effectively weigh the unseen mass lurking there. To do this, they use spectroscopy. Light from the galaxy's core is gathered and split into its constituent colors, a rainbow spectrum. Woven into this spectrum are dark lines, absorption features created by specific elements in the star's atmospheres. These lines are like cosmic barcodes. If a star is moving away from us, its light is stretched to longer, redder wavelengths, and these lines shift toward the red end of the spectrum, a redshift. If it's moving toward us, its light is compressed to shorter, bluer wavelengths, causing a blue shift. In a galaxy like NGC 1600, with its chaotic swarm of stars, some are moving toward us, some away, and some across our line of sight at any given moment. This jumble of motions causes the spectral lines not just to shift, but to broaden. The individual redshifts and blue shifts of millions of unresolved stars all blend together. The degree of this broadening, known as velocity dispersion, is a direct measure of how fast the stars are buzzing around in the galaxy's gravitational potential well. The team pointed their instruments at the heart of NGC 1600, a galaxy chosen for its immense size but not for any particular expectation of strangeness. They collected the faint, ancient light and analyzed its spectrum. As the data came in, a puzzle began to form. The velocity dispersion was high. Unusually high. The stars in the core of NGC 1600 were moving with astonishing speed, orbiting the center at hundreds of kilometers per second. They were moving far too fast for the gravity of the visible stars alone to explain. The mass of all the stars they could see was simply not enough to keep these stellar speed demons from flying off into intergalactic space. There had to be something else there. Something dark, compact, and tremendously massive, whipping the stars into a frenzy. The data was a ghostly fingerprint left at a crime scene, pointing to an unseen culprit. The quiet, placid facade of the galaxy was beginning to crack, revealing the furious gravitational engine hidden within. The numbers didn't just suggest a large black hole, they screamed for a monster. The calculations that followed were both exhilarating and deeply unsettling. Using sophisticated models, the astronomy team worked backward from the observed stellar velocities to determine the mass of the central object required to produce such frantic motion. They ran simulation after simulation, checking their data, calibrating their instruments, convinced that there must be an error. The numbers were simply too extreme. But the conclusion was inescapable, confirmed by multiple lines of evidence and independent observations. The object at the heart of NGC 1600 was not just a supermassive black hole. It was a behemoth of almost unimaginable scale. Its mass clocked in at 17 billion times the mass of our Sun. To grasp this figure is to confront the limits of human intuition. Our own galaxy's central black hole, Sagittarius A, is a formidable object at 4 million solar masses. The black hole in NGC 1600 is more than 4,000 times more massive. If it were placed at the center of our solar system, its event horizon, the point of no return, would stretch out far beyond the orbit of Pluto. It would be a shadow that could swallow our entire planetary system whole, a region of spacetime so warped that it would be fundamentally disconnected from our reality. But the sheer size was only half of the story. The truly shocking part was its size relative to its host galaxy. According to the trusted M-sigma relation, a galaxy with NGC 1600 stellar mass and bulge properties should host a black hole roughly 10 times smaller. This wasn't a minor deviation, it was a flagrant violation of the established cosmic order. It was like finding a blue whale living in a small freshwater lake, an organism that had somehow grown to a scale completely unsupported by its environment. This discovery sent ripples through the astronomical community. It suggested that our neat and tidy picture of co-evolution, of a balanced and regulated growth between black holes and galaxies, was incomplete. There had to be another way. Another, more violent path to becoming a giant, a path that did not rely on a steady diet of gas but on something far more dramatic. The existence of this ultramassive black hole in such a relatively average, isolated elliptical galaxy was a profound mystery. Most other known black holes of this class, the so-called ultramassive ones, reside in the centers of the largest, brightest galaxies found at the heart of dense galaxy clusters, cosmic megacities teeming with hundreds or thousands of other galaxies. In those environments, a black hole has ample opportunity to grow through mergers and accretion. But NGC 1600 is in a cosmic suburb, a small group of only about 20 galaxies. It is not a special place. And yet, it hosts a king worthy of the grandest empire in the universe. The question was no longer just how it got so big, but how it did so without the resources of a bustling metropolis. The answer, it turned out, was not in what astronomers could see, but in what was conspicuously missing. Music. With the confirmation of the monster's existence, the investigation deepened. Astronomers, now armed with the knowledge of what to look for, turned the unblinking eye of the Hubble Space Telescope toward the very heart of NGC 1600. They sought to map the distribution of stars in the immediate vicinity of the black hole, hoping to find clues to its formation history. What they found was a second, even more profound anomaly. They found an absence. A void where there should have been a crowd. In most galaxies, the density of stars increases steadily toward the center, forming a bright, sharp peak of light called a stellar cusp. This is the natural result of gravity. Stars, over billions of years, are drawn toward the most massive point, the central black hole, packing themselves into a dense and brilliant core. But the center of NGC 1600 was not a sharp peak. It was a broad, flat plateau. The core had been scoured out for a vast region, spanning over 3,000 light-years across. The density of stars was strangely and uniformly low. Instead of a bright, concentrated knot of starlight, there was a diffuse, eerie emptiness. The very heart of the galaxy was missing. This was not a natural state of being. A galaxy does not form this way. This was evidence of a past trauma, a cosmic wound from which the galaxy had never fully recovered. Something had acted like a giant gravitational bulldozer, plowing through the galactic center and violently ejecting stars from their natural orbits. Countless suns that should have been circling the core had been thrown out into the galaxy's halo, or perhaps cast out of the galaxy altogether, destined to drift as lonely exiles in the intergalactic void. The scale of this emptiness was staggering. A region thousands of light-years in diameter, larger than the distance from our Sun to the Great Orion Nebula, had been swept nearly clean. The prime suspect was obvious, the 17 billion solar mass black hole itself. But a single, stationary black hole, no matter how massive, doesn't do this. It attracts matter, it doesn't repel it. A single black hole creates a cusp, it doesn't erase one. This scoured core was the crucial piece of evidence, the smoking gun that pointed toward a far more complex and violent history. It suggested that the black hole had not been alone. This discovery fundamentally shifted the investigation. The problem was no longer just about feeding the black hole, but also about explaining this colossal zone of stellar depletion. The two mysteries, the impossible mass and the missing core, were not separate puzzles. They were two sides of the same coin, two intertwined consequences of a single, cataclysmic event that had unfolded in the deep past. The empty heart of NGC 1600 was like a perfectly preserved crime scene. The silence of the galaxy was the silence that follows a great explosion. The clues were now in place, an impossibly massive black hole, a scoured-out core, and a gas-poor environment that ruled out conventional growth. The challenge was to construct a narrative, a sequence of events that could connect these disparate pieces of evidence into a single, coherent story. The story would not be one of gentle growth and cosmic balance. It would be a tale of cannibalism, of a gravitational duel between two of the most powerful objects in the universe, a conflict that reshaped an entire galaxy and left behind the quiet giant we see today. The void at the center of NGC 1600 was not empty space, it was a scar. The most intuitive way for a black hole to grow is by eating. In the cosmic context, this means accretion, the process of pulling in and consuming surrounding matter. For a supermassive black hole, the ideal meal is a thick, steady diet of cold gas and dust from the interstellar medium of its host galaxy. As this material is drawn inward by the black hole's immense gravity, it doesn't fall straight in. Instead, it conserves its angular momentum, forming a vast, rotating structure called an accretion disk. This disk is a place of incredible violence and energy. Frictional forces within the swirling gas heat it to millions of degrees, causing it to glow with an intensity that can dwarf the combined light of all the stars in the galaxy. This is the quasar phenomenon, the brilliant death scream of matter as it crosses the event horizon. A sustained quasar phase, lasting millions of years, can funnel enormous quantities of mass into a black hole, allowing it to grow significantly. This is the standard model of black hole growth, and it works beautifully to explain the majority of supermassive black holes we observe, especially those that adhere to the M-sigma relation. However, when astronomers looked at NGC 1600 with this model in mind, it fell apart completely. Observations across the electromagnetic spectrum, from radio waves to X-rays, revealed a stark reality: NGC 1600 is a gas desert. It is an old, elliptical galaxy, unlike most of its kind. The vast reservoirs of cold gas that fuel star formation and feed black holes were used up or expelled billions of years ago. There is no significant accretion disk around its central monster. There is no brilliant quasar. The giant is, for all intents and purposes, starving. It is dormant, slumbering in the heart of its quiet kingdom, with barely a wisp of gas to sustain it. This profound lack of fuel presents a crippling blow to the simple accretion hypothesis. The black hole could not have grown to 17 billion solar masses by slowly sipping gas from its surroundings. There simply isn't, and likely hasn't been for eons, enough gas available to build such a titan. The feast is long over. Could it have grown by swallowing stars? While a black hole certainly will consume any star that strays too close, this is a surprisingly inefficient process for growth on this scale. A star is a tiny morsel for a beast of this size. To grow to 17 billion solar masses, it would have had to consume billions of stars, one by one. This process, known as tidal disruption, is a relatively rare event. The sheer number of stars required makes this an untenable explanation for its colossal mass. The evidence was pointing away from any kind of gradual, piecemeal growth. The monster in NGC 1600 did not get fat by grazing in a lush pasture. It must have consumed its meals whole. The solution to its impossible size and its barren environment had to lie in a different kind of cosmic event, one that was both incredibly efficient at delivering mass and capable of fundamentally altering the structure of the host galaxy itself. The quiet of NGC 1600 was not a sign of a boring life, it was the aftermath of a feeding frenzy so complete that it left the entire galactic core desolate. The clues of the oversized mass and the scoured core now pointed to a single, terrifyingly elegant scenario: galactic cannibalism, culminating in the merger of not just galaxies, but of the monsters that lie at their hearts. Music. The leading hypothesis that reconciles all the strange features of NGC 1600 is a story of cosmic merger and a gravitational dance of titans. This narrative begins not with one galaxy, but with two. Billions of years ago, in a younger, more crowded universe, two large galaxies, each with its own substantial supermassive black hole at its core, were set on a collision course by the inexorable pull of gravity. As they drew closer, their mutual gravitational attraction warped their shapes, pulling out long tidal tails of stars and gas. They passed through each other in a ghostly embrace, their stars rarely colliding but their collective gravity fields wreaking havoc. Over hundreds of millions of years, this dance of destruction continued. They pirouetted around each other, losing orbital energy through gravitational friction, until they finally merged into a single, larger, and more chaotic entity, the progenitor of the NGC 1600 we see today. In the heart of this newly formed galaxy, a second, more intimate drama began to unfold. The the two supermassive black holes, now captives in the same gravitational well, began to sink toward the new center. This process is governed by a phenomenon called dynamical friction. As the massive black holes move through the sea of stars, their gravity perturbs the star's orbits, creating a dense wake behind them. The gravitational pull of this wake acts as a drag, slowing the black holes down and causing their orbits to decay. They spiraled inward, inexorably drawn toward each other. Eventually, they fell into a bound orbit, forming a binary supermassive black hole system. This is the crucial stage, the event that holds the key to the scoured core. A binary black hole at the center of a galaxy is a gravitational slingshot of immense power. The surrounding stars, which would have formed a dense cusp around a single black hole, now interact with this dynamic, rotating pair. A star that passes close to the binary system enters a chaotic three-body dance. More often than not, the star is not captured but is instead violently ejected. The binary black hole system transfers some of its own orbital energy to the star, flinging it away at high speed, like a stone from a slingshot. This process, repeated over millions of years with millions of stars, is the scouring mechanism. The binary black hole system acts as a cosmic egg beater, clearing out the galactic core, depleting its stellar density, and creating the vast, empty plateau observed by Hubble. This act of stellar ejection is not without consequence for the black holes themselves. With every star they fling into the galactic halo, the binary pair loses a tiny amount of orbital energy. Their separation shrinks. They are drawn closer and closer together, their orbital speed increasing as the distance between them diminishes. The process is self-perpetuating. As they get closer, their gravitational influence becomes even more concentrated, and they become even more efficient at ejecting the remaining stars. They carve out an ever larger region of emptiness around them. This theory elegantly connects the two great mysteries of NGC 1600. The formation of a binary black hole is a natural consequence of a galaxy merger, an event that would create the large, chaotic elliptical galaxy we see. And the action of this binary system provides a perfect physical mechanism for scouring the core, explaining the missing stars. Most importantly, it sets the stage for the final act, the event that would provide the enormous burst of mass needed to create the 17 billion solar mass Titan. The binary black holes, having cleared their surroundings, were now alone, locked in a final, decaying orbit, destined for a collision of universe-altering proportions. The final moments of the binary black hole merger are an event of such extremity that it pushes the laws of physics to their absolute limit. After millions of years of clearing out their stellar neighborhood, the two black holes are now alone in the scoured core, their orbit having shrunk from light-years to mere light-hours, then light-minutes. They are now two shadows, two tears in the fabric of reality, each billions of times the mass of the Sun, whirling around their common center of gravity at a significant fraction of the speed of light. In this final, violent spiral, they become the most powerful gravitational wave generator in the universe. According to Einstein's theory of general relativity, accelerating masses produce ripples in the fabric of spacetime itself. And there is no greater acceleration of mass than two supermassive black holes locked in a death spiral. They are churning spacetime into a tempest. The energy they radiate away as gravitational waves is staggering, incomprehensible. For a fleeting moment, during the final few orbits, the power output of this single binary system in the form of gravitational radiation is greater than the combined power of all the stars in the observable universe shining in unison. Yet this colossal energy release is completely invisible, a silent storm shaking the very foundation of the cosmos. Music. As they radiate away this orbital energy, they spiral closer, faster and faster. The crescendo builds. The frequency and amplitude of the gravitational waves increase, screaming toward a final climax. Space-time in their immediate vicinity is no longer a passive backdrop, it is a roiling, dynamic sea, warped and twisted beyond recognition. Then, the inevitable happens. The two event horizons touch. In an instant that is both timeless and absolute, they merge. The two singularities, the 2 points of infinite density, combine to form a single, larger, and more massive black hole. The resulting object is not simply the sum of its parts. A significant fraction of their mass, equivalent to billions of suns, is converted directly into energy according to E equals mc squared, and blasted outward as a final, cataclysmic burst of gravitational waves. This is the ringdown, the final vibration of spacetime as the new, larger black hole settles into its final, stable form. This merger event is the answer to the mass problem. The new black hole, now weighing 17 billion solar masses, was formed not by slowly sipping gas, but by swallowing another giant hole. This act of cosmic cannibalism is the most efficient mass-gaining process known to physics. But there is one final, crucial detail. If the two merging black holes were not of perfectly equal mass, or if their spins were not perfectly aligned, the emission of gravitational waves would not be perfectly symmetric. More energy would be radiated in one direction than another. By the simple law of conservation of momentum, this asymmetric blast of gravitational energy imparts a kick to the newly merged black hole. The new behemoth recoils, like a rifle firing a bullet, with a velocity that can reach hundreds of kilometers per second. It is jolted from the exact center of the galaxy, sent on a long, slow oscillation through the core it helped to empty, before gravitational friction eventually causes it to settle back into the heart of its kingdom. This explains why the scoured core is so large and why the giant might not be perfectly centered. It is a king, born of violence, settling onto its new throne in the silent, empty hall it created. This, then, is the secret history of NGC 1600. Its quiet, golden light is a deceptive shroud. Its placid state is not one of peace, but of exhaustion. It is the aftermath. The great merger happened billions of years ago. The gravitational waves have long since propagated across the cosmos, their energy dissipated over unimaginable distances. The scoured core is the permanent scar from the binary's violent dance. The colossal black hole is the merged remnant, the victor of the titanic struggle. And the galaxy's lack of gas and new stars is the final consequence. The energy unleashed during the galaxy merger and the subsequent quasar phases that may have been briefly triggered would have heated and expelled any remaining gas, sterilizing the galaxy and ending its era of creation forever. The quiet we see today is the direct result of the unimaginable violence of its past. The monster did not grow in a quiet town. The town is quiet because the monster had a war, and it won. NGC 1600 is a monument to this process, a perfectly preserved laboratory for studying the most extreme gravitational events the universe has to offer. It stands as a testament to the fact that the cosmos evolves not just through gradual, gentle processes, but also through sudden, transformative cataclysms that can reshape the destinies of entire galaxies in the blink of a cosmic eye. It is a sleeping giant, whose dreams must be of a time of unimaginable fury. We have journeyed to a silent, ancient galaxy drawn in by a profound cosmic mystery. We found a kingdom that appeared to be in a state of eternal, peaceful slumber, yet at its heart, we discovered a king of impossible proportions. NGC 1600, with its soft, golden glow, seemed the last place in the universe to harbor a 17 billion solar mass black hole, a monster that shattered our neat and tidy rules of cosmic ecology. The central question was how? How could such a behemoth arise in a place so devoid of sustenance, so deceptively placid? The answer was not found in what was present, but in what was absent. The key was the galaxy's missing heart, a vast, scoured-out core, a wound thousands of light-years across. This scarred tissue told a story not of slow growth, but of a violent past. It spoke of a time when this galaxy was not one, but two, each with its own dark sovereign. It told of a cosmic merger, a gravitational duel, and the formation of a binary black hole system that acted as a relentless engine of stellar eviction, clearing its own arena for the final conflict. The resolution came in a cataclysm that defies imagination, the final, violent merger of the two black holes, an event that shook the fabric of spacetime and forged a new, titanic entity in a flash of gravitational radiation, solving the mystery of its incredible mass. The quiet of NGC 1600 is not the quiet of birth or of life, but the profound stillness that follows a titanic conclusion. It is the silence of a completed history. The story of this galaxy reveals a deeper truth about the cosmos, that it is a place of cycles, of creation born from destruction. Galaxies collide and merge, creating larger, more chaotic structures. Within these new realms, black holes engage in their own gravitational battles, culminating in mergers that produce ever larger giants. This violence, in turn, shapes the final state of the galaxy, expelling its gas, ending its cycle of star formation, and setting it on a path toward a long, quiet retirement. The serene, elliptical galaxies we see scattered across the universe are not simply old, they are veterans. They are the survivors of the most extreme events the cosmos can produce, their peaceful facades belying histories of unimaginable fury. NGC 1600 is not an anomaly that breaks the rules, it is a profound example of a different set of rules, a more violent and dramatic path of evolution. It teaches us that to understand the universe, we must listen not only to its grand symphonies but also to its deepest silences, for it is in the quietest corners that the echoes of the greatest storms can often be found. The cosmos is both a cradle and a tomb, a sculptor and a destroyer, and its greatest works are often hidden in plain sight, waiting for us to ask the right questions. What would you have done if you could have been a witness? To stand at a safe distance and watch two galaxies merge, their stars painting the darkness with streams of tidal light. To feel, not with ears but with the very essence of your being, the silent, growing tremor in space-time as two black holes, each larger than a solar system, spiral toward their doom. To behold that final, incomprehensible moment of union, when the fabric of reality itself was torn and reforged, unleashing more power than all the stars combined. We can only see the aftermath, the quiet kingdom and its oversized king. But in that silence, we can still hear the faint, ghostly music of that cosmic collision, a reminder that the peace of the present is almost always built upon the violence of the past.